is in addition to the substitution effect and the income effect, there is a wealth effect. Discounting of future income. We didn't have that because we didn't have any future income here. Now, on the other side of the whiteboard, we do have future income. And the future income is discounted more strongly if the interest rate goes up. And that has an additional effect. And so by the end of the day, if sigma is smaller than 1, so the intertemporal elasticity of substitution is greater than 1, then everything goes into one direction and people save more if the interest rate goes up. Unlike in the y2 equals 0 case, we even have an effect on savings if sigma equals 1. So this is 1 here, right? Because if sigma equals 1, then the thing becomes a 1. But this is still, I mean, given that sigma is greater than 0, still the numerator is increasing, and so savings are increasing if the interest rate goes up, and if this interest rate, if the intertemporal elasticity of substitution is smaller than 1 because sigma is greater than 1, then the result is ambiguous. It depends on the relative strength of these effects. Now, this was almost an hour of basically deviating from the slides, but you will see in a second that I'll come back to the slides and you see that again. But this is a very important investment, because when you talk about macro, by the end of the day, you talk about consumption, investment, government behavior. And understanding consumption is super important, right? I mean, and understanding consumption, with consumption being the flip side of savings in a dynamic model, you have to understand these effects. This is very basic, but it's very, very fundamental. And I hope that it also illustrates that as economists, we understand more than many other people, because many other people say, oh, the interest rate goes down, and nevertheless people are saving more. That's weird. People are not behaving rationally. And as economists, we can say, no, wait a minute. People are behaving rationally. They are maximizing utility. It's just that there's an income effect, and the income effect is something that comes on top of the substitution effect, goes into the other direction, and might actually generate results that naively might seem non-rational, but in fact they are very rational. Okay, that was what I wanted to say on this. And now let me continue with my OLG model. And let me guide you back to this equation, and let me just show you that this is basically that equation, right? Now, we have y1. Now, this is what people earn when they're young. This is y1. Then with the 1 plus beta to the power of 1 minus 1 over sigma, right, in here. And we have the 1 plus r to the sigma minus 1 over sigma, right? That's what we were doing on Friday. The new thing is, in addition, is that when When mu goes up, savings also goes down. And that's because of the fact that if you have more children, you're basically sharing your income with more people, so you have less to save. That's the effect, right? Remember, offspring's consumption reduces own consumption, parents' income less savings divided by 1 plus mu t. So when you take all this into account, what you get eventually is you get if you have more kids, then you save less.
Sorry, what does subscript T show here?
Subscript T refers to people who were born in T minus 1 and were children in period T minus 1, who are grown up and working and saving in period T, and who will be retired in period T plus 1. So this is the generation T minus 1, basically. Now, when you look at the evolution of the net international investment position, so the change between BT plus 1 minus BT doesn't matter. One, that's if she wants to come, that doesn't disturb me at all. Okay, so here's the current account balance, which is now. Please note that these people this is savings. Now, this is the savings. This is the stuff up here of the generation born in period T minus 1. Now, you subtract the savings of those people who were born in period T minus 2, so the preceding generation, times, so this is the size of that generation times the savings of that generation. And the important thing to see is that demographics affects the current account through two channels. A, by affecting the size of generations, and B, by affecting what the individual member of a generation actually saves. So this may be large, A, because this is a large generation, and because these people save a lot. And that's exactly what we're going to see in the next or in our little example. Okay, so this is the size of the generation. This is the number of people born in period T minus 1. This is the number born in period T minus 2. This is what these people saved when they were old enough to save, namely when they were of working age, and the savings that they carried into period T plus 1. And this is the savings that the previous generation carried into period T, because these guys were born in T minus 2.
So this means like, for example, the size of a generation may be small, but if the B, like what they actually save is significant, still can offset.
Exactly. Exactly right. And you see that, remember that mu T, well, let me put it in here. Mu T is defined as NT over NT minus 1. Right? It's the number of children where is that? Here. Well, mu T is NT over NT minus 1. Mu T plus 1 is NT plus 1 over NT. So, and Nina, I love that comment, because how much you save depends on how much children you have. So basically, this may be a small generation, but they save a lot because they have very little children. Or it may be a large generation, but they save very little because they have a lot of children. So you have basically not just, you have the demographics entering through two channels. Through how large is the generation and how much do individual members of that generation actually save. Good. Now, saving is a fascinating thing. And what I took here is data from a German population survey where people were asked how much they were saving at different parts in different years of their life. And so this is the share of their disposable income. And you see, in fact, people do save more as they become, right? So there's actually people between 18 and 25, they already save. Well, that's also because, I mean, these people already earn a salary in many cases. Then they save a lot while they are in prime working age, so to speak. And then saving goes down. Now, interestingly, it never actually becomes zero. And this is where it goes against the model. Because in our model, when you retire, you have negative savings because you essentially eat up your savings. Here we see that at least in Germany, people save less, but they never save zero. So my mother is 86, but she still saves, right? And especially when they get very old, people save because of various reasons. The first reason is they want to leave something behind for future generations. Secondly, they are scared that by saving too little, they might not have enough if they get very old. It's called longevity risk, right? So